All right, last thing I'm going to show you is what you deal with if a solution is becoming more acidic. Let's see. Let me answer the question here. Which of the following substances will be more soluble in acidic solution than a basic solution? So what we're looking at is whether it's better in a base or an acid. Okay, so we're looking whether it's an acid or a base. Now you should remember that acids are hydrogen ions, bases are hydroxide ions. Okay, we're going to look at this qualitatively to kind of see how this effect is going to be played out in our solubilities. To be honest, I'm not going to hold you to too much of this until after we cover the chapter on acids and bases. So actually, I'm only going to show you this first one here because you could probably understand that one. You have to know something about weak acids and bases to understand B and C. And D, well, it just has nothing. It's just basically neutral. It doesn't have any effect at all. But if I were to have a solution that was the acid, that means I have hydrogen ions in that solution. If I have a base, what I'm going to, oh, that's a terrible beaker. Let's draw that again. Still not too great, but okay. And over here I'm going to have hydroxide. Over here, so that would be my basic solution. Okay. So if I take this nickel hydroxide, what I want to know is how is this going to be affected if I put it in either one of the two solutions? Well, I'm looking for more soluble. I want the solubility to go up. So let's look at the equilibrium expression for this. So for nickel hydroxide solid, we have the dissociation. So nickel 2 plus and 2 hydroxide minus. All right. What I want to have happen is I want solubility to go up. So what I'm looking for is I'm looking for the reaction to shift in this direction. I want to maximize my pull in this direction. So I want these nickel ions or these hydroxide ions to get used up. I don't want to have more of them here. So if I put this nickel hydroxide into this solution, this is that common ion effect, right? We just saw what happens due to common ions. So the common ion effect. So because the hydroxide is in here and I'm trying to dissolve this into a hydroxide that's already in there, it's not going to shift very far to the right at all. So it's not going to be very soluble in a base because it's basic itself. It's not going to have any real ability to produce more hydroxides. So therefore, in this case, this one is more soluble in an acid than it is in a base. Why? Because this acid that's here, this hydrogen ion that's in the solution, will actually come in contact with the hydroxide, and that H plus that OH minus is going to make water. Okay, so what's going to happen is the concentration of my hydroxide goes down. So I put this nickel hydroxide into the acid over here. It dissolves and dissociates. This reacts immediately, gets used up, and is gone. So according to Chatelier's principle, more of this reaction will shift to the right. I get more hydroxide, diminishes it, gets used up by reacting over here with the water, with the acid to make water, and again it shifts and it shifts and it shifts. Now this depends on the concentration of the acid, which we don't really need to know. We just need to know that it will increase the solubility. Okay, so that's some basic calculations with solubility. Hopefully that covers some of it. In the next video I'm going to cover precipitate reactions and how to predict whether a precipitate will form. Alright, so I'll see you in class, guys.